Rosalind Reed. I'm the executive director of the Institute for Applied Computational Science, which is something I want you all to hear about. This is a historic moment because the Institute has just been launched, and we're taking over what was started as the Rockstar series. Did you know that? We started these colloquia a couple years ago by combining CS faculty and something that was called the Initiative in Innovative Computing, sort of looking for intersections between fields in science and computational questions, and looking for the people working really on the leading edge. So I'm very proud that we're continuing them this year, and that Ben Shneiderman is our first speaker, and Christoph Gaius is going to do the introduction.
Hello, my name is Christoph Gaius. I am one of the new faculty in computer science. I have to stand close to you because otherwise it won't get recorded. It's my enormous pleasure to introduce Professor Ben Shneiderman. Professor Shneiderman is in the Department of Computer Science at University of Maryland in College Park, and he's the founding director of the HCI lab there. And the HCI lab has run for more than a quarter of a century now.
Right.
So it's a little scary introducing Ben. I'll just, there's a long list of awards on his website. I'll just mention that this year he was elected into the National Academy of Engineering. And he's also...
Well, thank you. Trumpets would have been fine, but that was really good.
Okay, now we're the serious stuff. He's an ACM fellow. He also received the ACM Thai Lifetime Achievement Award. Amazon says that he has published more than a dozen of books. ACM Digital Library cites more than 350 papers, but both are probably underestimates. Ben has asked that I mention that I make this introduction personal, so here it is. I first learned of Ben as a not just enthusiastic but militant defender of good user interface design. I first met Ben about 10 years ago when there was still when we were still in the period of irrational exuberance about intelligent agents and novel natural ways of interacting with computers that often involved a lot of machine intelligence. And Ben was often on the other side of the fence, very vocally. And indeed, my first interaction with Ben when I was teeny-weeny grad student and when I was working on intelligent user interfaces that try to adapt themselves to their users was Ben telling me that I was misguided. But he said it with such a smile that I wanted to hear him again. So shortly afterwards, I forwarded him a paper that actually had some quantitative evidence showing that it was okay to be intelligent from time to time, to which Ben's response was that I was disturbing. I felt I was moving up in the world. So, okay, I think that's enough. Oh, I'll mention just one more thing. Ben published his book on database management systems the month I was born. And I consider it a great honor.
I do remember those really early interesting discussions, and Krista was working at Microsoft about adaptive toolbars, and he did actually find his solution was really creative, and I thought was on the right track of creating a separate tool, keeping the toolbar stable, the spatial stability, but creating a separate toolbar where there were the adaptive parts, and I thought that was a useful way. So I was pretty positive about the outcome of that, and I thought our discussion's fruitful. So I brought a little souvenir and a gift of the HCIL T-shirt for you to have to be an honorary member of HCIL, and I hope you'll come to Maryland and wear it when you come to visit. All right. And Krista's made the introduction in a nice way. There are a lot of affiliations, but I am most proud of this group at Maryland that since 1983 has been looking in a serious, in-depth way about an interdisciplinary way. And that was owned by computer science, but now jointly owned by the rapidly emerging iSchool at Maryland, where the action really is, and our lab has physically moved there. Ben Peterson took over directorship in 2000. Allison Druin is the current director, and it's a lively community of 45 or 50 people, and partnerships with psychology, sociology, political science, and the wonderfully titled Maryland Institute for Technology and the Humanities, MITH, and many other groups. Our website has 450 papers, some 200 videos, and 40 pieces of software, and lots more, so come visit. Some of you may know me from the book Designing the User Interface. The 5th edition emerged this past year. I'm pleased to acknowledge Catherine Plaisant, who joined me as co-author. She's been my research collaborator for 25 years, and it's been just very satisfying. And a lot of the work I talk about is shared with her, and also other people in this room who I will mention. The new things to notice are social media. And social media became a more substantive topic in the 2004 edition of the book. There was no YouTube. There was barely a Wikipedia. Facebook was a glimmer. And all these new things have happened. And the real transformation from the beginning of the book was the first edition was written for a few specialists in medicine and programmers and air traffic controllers. And by now, we have 4.5 or 5 billion cell phone users, a billion music users, several billion digital photography users. And so there's a great success story for this community of HCI that we've designed these interfaces which enable so many people to participate and benefit from these advanced technologies. So social media became a large topic in this 5th edition. And the topics of search and visualization each gained their own chapters. We've had the pleasure at Maryland to work with many important federal agencies. So we've worked with the Library of Congress on the 7 million objects in American memory, the handwritten letters of George Washington, the notebooks of Walt Whitman, photographs of the architecture of Washington, D.C., and 200 other such collections. We've worked on many projects for National Library of Medicine. I think most notably the Visible Human Explorer, which was an early interface that enabled people to explore these large data sets of human anatomy. We've helped NASA build interfaces to explore the remote sensing data sets, and worked with Bureau of Census, and that grew into a larger project with 70 agencies to help them build websites that would enable citizens or residents to find what they need and then understand what they find. And I'm pleased here to acknowledge my collaborator in this and dear buddy, Gary Marcionini, now the dean at the University of North Carolina's iSchool. More recently, we've worked on recovery.gov and helping them design a website that would enable, as Obama said, to citizens to track every dime that was spent out of the $787 billion. In fact, the 1,000-page bill on page 171 says essentially, thou shalt build a user-friendly visual interface that enables citizens to find this kind of data. I can't help but tell you about the good work of my colleagues Ben Peterson and Allison Druin, a project that my role is as a cheerleader, but they have over the years with NSF and IMLS and other support, now Google and others, built a library of 4,400 of the world's best kids books. The books are in 54 different languages. The interface itself is in 16 languages, and it's just been a great research platform, as well as millions of visitors have benefited, that children and language learners from around the world are able to find different kinds of books, including ones with red covers, or make-believe books, or books about frogs or happy endings. And so it's just a great resource. Give it a look. It's just a great piece of work. And it's, I think, symbolizes the kind of work the lab likes to do, that is important ideas that get fielded, get put to work, and make the world a better place. All right. So that's the opening pitch. The narrower focus for today is about information visualization. And with Stu Card and Jock McInlay, we tried to define this topic some 10 years ago in a book that collected 47 of the most important papers and 60,000 of our own words. And we tried to make the case for information visualization as distinct from scientific visualization. I'm going to try to lay that story out. And I love Stu Card's subtitle of Using Vision to Think, that your visual perception is not like a camera. We are not machines after all. We don't just take the input through our eyes, but our optic nerve and cortex process it and allow us to make decisions visually in a very rapid way. And there are remaining sets of challenges, and I just want to sort of lay out the territory, show you one visualization that's a little bit flattering, but tells you something about the power of visualization to show you the field of visualization. This was done by Kati Borner and her students at Indiana University, based on all the data from the information visualization conferences. And the size of each node, which is an author, is the number of papers published. And the strength of the links indicates the number of co-authorship patterns. So this image has become very iconic because here is Card, McInlay, and Robertson, a team from PARC, or Xerox PARC, who worked together under well-funded circumstances with a few collaborators like Paroli and Rao, and you can see that tight linkage of repeated work. The book that I did with them gave this little green link between me and them. But I get a little more papers because I have the university profile of lots of students around me who worked together on their projects, and we developed a lot of work. So I get to be co-author on a lot of papers, but there's a lot of students surrounding me in that environment. And you see the other clusters, if you know, there's the Georgia Tech group, and there's the University of Minnesota, and where we got, I guess, this is CMU. So there's the German group at Konstanz. And so you get to see these patterns, clusters, gaps, and that's what we're after. That in visualization, we're looking at relationships. In this case, a network is a way of seeing it. And that's what when I asked before the questions about your background, what I was looking for is, you know, not where you're sitting, but I wanted some special glasses so I could see the interrelationships. And it took a while to understand that the main cluster was computer science, but there were a few outliers, including Roman history and, you know, psychometrics. And so there were some clusters of different groups and some outliers. And I'd like to be able to see those kind of relationships in a more orderly way. I might like to see the temporal relationships. Which of you are sort of moving from undergraduate to graduate studies, or are, you know, progressing in your career in some way, or have changed directions? There's so many questions of, you know, structure, hierarchy, organization, network, and temporal patterns that I'd like to be able to answer with a special pair of glasses. And that's what I think this field does. Another sort of overview of the issues is about the methodologies of evaluation. And these slides come from the contests that Catherine Plaisant has run for 6 years to try to develop assessment techniques for visualization tools. And this is ranged from the traditional controlled experimental studies and usability studies that are so well established in human-computer interaction. And we've moved, and others have moved, more towards these ethnographic observational case study approaches under what we call multidimensional, in-depth, longitudinal case studies, or MILCs. And I'm going to use that, you know, as some of the examples here. So the point is that visualization, and my title focuses on discovery. And that's very different from the kind of motor skills or perceptual tasks that were studied in the human factors literature. And we're interested in insight. We're interested in discovery. And that doesn't happen in a 2-hour usability study, okay? It happens over weeks and months as people learn the new tools, as people reframe their processes of problem solving. That's really the hardest part. How do we change the way people think? How do we measure that we've changed the way people think? And our goal is to increase their capability to make discoveries, to derive insights from data. Okay? So I hope when I'm done today, I'll have given you a few examples, and we'll leave you with the feeling of, I could do that, and that I could use those tools, and it might change the way I look at the data that I have. I'm very pleased that Martin Wattenberg is here. He's the developer of Many Eyes, and that's changed the way I teach my classes and talk about the field. Many Eyes contains now 20 different visualizations. You upload your data, create a visualization, save it to the web, and then can write a comment, and others can comment and comment and comment on it. And it enables you to play and try some very innovative and different kind of innovations. And by now, how many data sets are up there? Is it 80,000?
Yeah, around, I haven't
right,
lately.
right. But it's on the order of 100,000 data sets have been uploaded by many people who have looked at this and commented on it. So if you want to get started, here's a good place to start. My other sort of, tour d'horizon of this topic says, let's look at the impact in terms of business. We've gone from 15 years ago, a new flaky idea by a couple of weirdos with some new technologies, to I would say, mainstream technology. Not that everyone's discovered it yet, but the small companies and the spin-offs like MayaViz from CMU got bought early on by General Dynamics, and then Microsoft bought ProClarity, and you get this succession of the middle-sized fish eating the little fish, and then the big fish eating the middle-sized fish. So, the Insight got bought by Business Objects, and then Business Objects got bought by SAP. And every one of the business intelligence platforms that had acquired visualization tools got bought by the bigger integrators. And, at the bottom is our story. I'm just going to be brief about talking about Spotfire. How many have used Spotfire? I hear it's on the chemistry platforms here. But Spotfire was developed in our lab, and the paper is in 1994 Chi conference. Chris Olberg formed the company in 1997, and it grew to 200 people by 2007 when it was bought by Tibco, and so remains a subsidiary of Tibco. And that was really a very satisfying effort for me. I was on the board of directors for 5 years and began to understand how the dynamics of business work. So this is just a little peek at Spotfire. It's one of those rare screenshots where it is the moment of discovery. This was sent by the biological researcher Nick Thomas at GE in England. Spotfire's main success story has been pharmaceutical drug discovery. All 25 of the leading pharma companies use it. The companies like Pfizer and Novartis have 3,000 licenses and very systematic ways of using this tool for making these very tough discoveries. The genomics and cheminformatics now and many other places use this. So this example just shows a few of the points. It shows a few different kind of visualizations from the Affymetrix plate and the mosaic and 3D representations, as well as the control panel. That's really important to me. These double box sliders, which let you filter and control, are really the key to the rapid presentation and exploration. And the discovery is here. Now, you may not notice that, but Nick Thomas did, that the gene RBP1 was far more active than expected. And that was significant because it controls the embryonic development and the visual system in embryos. So that was important. That was a surprise. And that shows up with this bright red spot over here. And it's echoed by the bright spot here. And it's represented in this as well. So the idea of multiple parallel coordinated windows. If you select a group in one window, it highlights in the other window. If you move any of the sliders, it moves. It filters out all the rest of the data. And this works at 100 millisecond speed on up to about 1 million item data sets. And now they've pushed it in some cases to 100 million item data sets. So that's another issue. But the issue is not the number of data items, which you can deal with billions by the proper aggregation methods, but the complexity of the data. And this is a sort of a typical, I would say, 27 windows is not quite enough to understand the structure of the data, but you can quickly see and compare the distributions of data and the trajectories of information and recognize patterns if you know what you're looking for. So we see just many opportunities for this. There is a free download version evaluation of Spotfire that you can try and take a look at on the website. But I sort of want to go beyond this idea and just take where we've been in the last 10 years. So the idea of larger display spaces is becoming quite widely accepted and moving to 10 or 100 megapixel displays for individuals or larger displays for groups to look at. And I think we'll see increasingly those. In our lab, we buy the 2400 by 3200 pixel displays, and sometimes you want 2 or 4 of those because there's a lot of data to be looked at in the world, and the data often has complex structures that may require you to look at a lot at one time. Switching screens, clicking on tabs, scrolling are all extreme disruptors of your cognitive processes that take you out of the problem domain and focus your attention on the interface domain, and we want to minimize that. Okay? Now, there's also great progress in using it on small displays and portable displays. And I'm not sure I want my radiologist or air traffic controller to work on an iPhone, but it does provide value, and I think increasingly we'll see good visualizations on small displays. Okay? So the lessons we've learned begin here, and each line of this slide represents one project where we struggled for weeks or months to find an adequate design. And the message I scribbled down one day was overview first. Show the whole data set, even if it's 1 million or 1 billion items. Show its extent, show the clusters, the relationships, the gaps, the outliers, the anomalies. Okay? Then allow the user to zoom in on what they want, filter out what they don't want, and then click for details on demand. Now, this is not a strict design principle, but it's kind of a pattern that suggests, and it began to catch on, and many people have cited it. Some people have objected to it. People have joked about it. People have extended it. And there are more than 1,400 citations to this in Google Scholar. So it certainly had an impact, which is pretty nice for a kind of obscure conference that it appeared at. And I think its vitality is that it emphasizes the centrality of human decision making. It's not that the machine did the job for you. It's that you got an overview and you got an understanding of what's going on. You decided what to zoom in on. You decided what to filter out because you had a plan. You had a hypothesis you were testing, and then you clicked for details on demand. So there are many ways to implement it. But it was interesting in the discussions today. This issue of the user being in control is very important, I would say, and I kept reiterating that point. And this is a way maybe of saying what I've said rather boldly, and Christoph said sometimes I'm bold in my statements, but that computers have no more intelligence than a wooden pencil. And we're going to build powerful tools with powerful automation in them, but we are always going to assert the centrality of human control, and the responsibility for success and failure is inherently human. All right, so here I promised you a little bit of the layout of the territory and the table of contents for the talk. Scientific visualization is a well-established field. Many people here work on that. Hans-Peter Pfister also. And there are geographic information systems and 3D molecules and CAD/CAM and architecture tools. And in all those cases, the issue is location, 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 just like real estate. Where is the plaque building up in the arteries? Where is the turbulence greatest in the airflow over the wing of the aircraft? Okay? Where is the storm forming? Okay? So those where questions are the guiding ones for scientific visualization, and that work continues after 50 good years of work. The newer kid on the block, the 15-year-old, is this territory. The multivariate or high-dimensional data, Spotfire and other commercial products like Tableau, and hundreds of university projects have worked on this topic. We're going to take a little bit of look more at temporal data, our own work here and other newer products I'll mention, and tree structure data, and then the tough one in the closing arguments about network visualization. Okay? So again, the motivation, some of you, and the resistance I sometimes get as well, visualization's nice for showing results and pretty pictures. But really, I want to use my statistical algorithms and my machine learning and my data mining methods, because that really tells me the stuff that, you know, the visual stuff is sort of secondary. This famous set of data from Anscombe, Frank Anscombe, a statistician, a contemporary of Ed Tukey, actually brother-in-law to John Tukey, the famous statistician. But Anscombe gave this set 4 sets of data. And I'm going to ask you, what do you see here? What's interesting about these 4 sets of data? What can you tell from looking at the numbers? Okay, 2 very good observations. That's a good start. I'm going to have a few of these challenges. The 4th one has a kind of interesting pattern. They're all 8s in the X, except one of them. And then notice that 1 and 2 seem to be similar this way. Okay, what else? Well, it's kind of tough. Even with just, you know, a dozen rows of data, it's hard to make some sense and see where the problems are, what the anomalies might be, where the clusters are, what the relationships are. I mean, can you tell me which one of these shows a linear relationship? Even that's going to take you a little while. So you say, well, I should be able to use my statistical tools, and if you run, you'll find that all 4 of these have the exact same statistical parameters. The mean, variance for x and y, as well as the correlation coefficient and linear regression are all the same. So, and this is a problem we see a lot, you know, that the statistics don't always give you the full picture, and you're going to miss something. But when I look at this, you're going to go, oh! Immediately, in a couple of 100 milliseconds, you can see what's happening here. The first one has a sort of loose correlation. The second one is a curvilinear or quadratic. And the third one is very linear, except one, is it an outlier or is it an anomaly? I'd say it's an anomaly. Something's wrong. That data might be bad. Okay? And I would say visualization earns its pay if only for data cleaning. Okay? The majority of data sets people bring to me have something wrong with them, and they've been looking at this for months, and they never knew because they were looking at it with SQL or other tools, and they just couldn't tell that one data set of 6,400 patients that were studied for, you know, the length of stay in hospitals, men and women, discharge rates, insurance coverage. Do old people get better treatment or worse treatment? Do young people get better or worse treatment? 3 of those patients were 999 years old, and they never knew that. Another case, I was brought a year's worth of temporal data. April was missing, and they never knew that. Okay? Another case had 600 data items. 41 of them were exact copies of each other. Somebody had cut and pasted 1 too many times, and the data items came in wrong. And those things happen, as I say, the majority of times, and you'll see them. So one advantage of visualization is to do it at the beginning and see what the distribution looks like. Are there anomalies or in the data? Are there things that need cleaning up? Or do I need to split this into 2 groups because there are 2 very different distributions of data? So that's one of the motivating cases. But let me move on to show you demos, and that's my main focus for today. So I'll start with temporal data, which is pretty straightforward, and show you Time Searcher, which is the PhD work of Harry Hochheiser. This very simple case shows 223 stocks and their closing prices over 13 months. So we could scroll through. Some go up, some go down, some jiggle around, some are kind of flat. And it's hard to get any sense from looking at individual ones, but you know, you've already heard my principle, which is overview first. So I put all 223 of them over here, and now, anybody see anything interesting? February, right. February seems to be highly volatile. So I grab my time box, and I say, let's look at the peak first, and immediately I get 2 interesting features, I hope you can see there, that everything that rose in February fell back down in March. And then there's this funny anomaly or outlier here, adaptive broadband, which rose in January ahead of everybody else. Now, what was it? Did the investors, were they really clever? Did they anticipate it, or was there some other special feature of that stock that people that made it very special? We don't know. These kind of analyses don't tell you cause and effect, but they guide your further investigations to see. So you say, well, let's look at the bottom, and the bottom is less sharply defined. It has a little bit more complexity in it. We'll leave that there. But the question we got from our genome explorers as well as our stock market friends is, what starts low and finishes high? So we said we can do that. So we can find those. And do they go up monotonically, or do they jiggle up and down, or is there any particular good or bad month? So you could look for those things. Or you could build a pattern that says, I want the stocks that start low, go up, and then they stay up. All right? So we can take that pattern, and now we can go hunting for those stocks early in the year, late in the year, and look at different price ranges for stocks that match. And then they said, well, you know, what about the ones that go the opposite direction? So Harry said, we can do that, and you get to flip it around. And you can, if you want, close the gap a little and look sharply at the ones, or you can open it up and look more, okay? So it's kind of interesting. This was submitted to a data mining conference, and one of the reviewers said, well, there's nothing new here. It's just, this could all be done with SQL, because it's just a greater than this and less than that, and greater than this and less than that, and greater. And it's true. This little query is about 45 lines of SQL, and if you typed it correctly, it might take you at least 100 seconds. But the capacity to move it around 10 times a second, I would say, you know, gives me about 1,000 to 1 advantage over SQL. So I'm happy to take that. All right. Now, any questions about this? Just, that was real quick. Any comments or questions? This was our early thinking about it, and we were creating, as I said, the tools that allow humans to explore. But I promised you something a little more ambitious here, which is I would integrate the statistics. So why don't I find the ways to place this pattern in the best place to find the most? So I could begin to see about ways of integrating statistics with visualization rather than just the human exploration, and that's certainly where we went. There are about 35 other features that were suggested for Harry's work, and they're in his dissertation, but I think the basic idea really is strong here. Now, in doing this, the design goal was to have 200 data points, time points, and 10,000 stocks. So that's a fair amount of data, and Harry succeeds to do that and still get the 100 millisecond updates on the display or manipulation of the information. And so the computer science part were the algorithms and the data structures that put this in the high-speed store in a way that let you explore these higher dimensional data sets. And it turns out with Spotfire and with Time Searcher, we early on discovered that the traditional data structures of KD trees, quad trees, and grid files that you use for multidimensional data just didn't work. Okay, they're just inefficient. And so rapid sweeps through linear arrays became the strategy that was employed to get this to work more effectively. All right, any other questions? This is free to download and from our page called Time Searcher. So Chevron Texaco came to us and said, hey, that looks good, but you know, 200 time points is not going to do it. For every well we have, we collect the pressure and temperature at the top, at the middle, and the bottom every 10 seconds for a year. And we've never seen our data. So we said, okay, we'll go for 10,000. And we did much better than that, but our design goal was 10,000 points. Even though the screen was only 1,000 pixels wide, we're able to show, you know, hundreds of thousands of points by a summarization or overview. So here we're looking at a simpler data set of weather data for 5 years from Italian cities, and you can see the annual patterns of sunlight here we're looking at, and the summer peaks and the winter troughs here. This little orange box, the field of view box, represents the information that's exposed here, 2 months worth of data here. And in Time Searcher 2, you can select a pattern that you like, in this case 2 cloudy days, with 7 sunny days in between, and then say, find the patterns that are similar. And in fact, these red triangles indicate the success of finding a match. They're not exact matches as Time Searcher 1 did, so we've used the statistical measures and Euclidean distance and other ways to facilitate a little more of the integration of statistics with visualization to suggest where you should be looking because there are patterns that may be of interest to you. Okay? So that's Time Searcher 2, written in C#.net, free to download as well. Time Searcher 3 took it a little further to do forecasting, and you can take a look at that and the papers and the videos online. At the same time, we were also looking at another kind of temporal data, which was we called categorical event data. Instead of numbers that went up and down, many data sets have point events, and Lifelines was that version of a patient history. We were after a 100-year patient history with 10,000 medical events, and if you click on the sonogram, you see the sonogram and the fetus right over here. If you click on the x-ray, you see the x-ray. You click on the EKG, the details come on demand. You can filter out, I guess I just should say, this is the doctor visits, these are the hospitalizations, these are the lab tests, the medications, and other treatments here. So you can filter, zoom. Here we're zoomed in on a 3-year period, and the gray vertical line is today. So this person is pregnant and will be pregnant for the next 3 months. They've been diagnosed as having diabetes, so they've gotten insulin and an increasing dose of insulin and Lasix to counteract the side effects of insulin for pregnant women. So you get a quick overview. You get to see, you can filter, and you can zoom in on what you want, and then click for details on demand. We built this, and it's now been integrated. About half of the current commercial systems have some version of Lifelines, including the Harvard I2B2 system has a version of this, and other tools like Data Montage and Palantir were inspired and built tools like this. But we, Catherine and myself, always had the dream to go further and say, what if we had not just one patient, but 1 million patients, or 100 million patients? How might we look for patterns? And so that takes us to Lifelines 2, and I'm very pleased that David Wang is here. His PhD work completed in May. He's now come to work at Harvard Medical School and Partners Healthcare here in Boston. So this is David's work, and we're going to hear his narration of this data set. We're going to be looking at it. You know, it gets a bit complicated. Understand that patients for certain medical tests, get an injection of contrast so that the X-ray will show the pattern of flow of blood in their veins and arteries. However, about 7% of the population have an adverse effect, a response to this contrast injection. The way you watch out for that is you test their creatinine levels before, 2 days before, and then sometime in the couple of weeks after you test, maybe multiply, their creatinine levels. If their creatinine levels get higher, that's the danger sign. So what you're looking for is a temporal sequence that starts with normal creatinine, the radiology contrast, followed by a higher one. Okay? And here is David's narration.
In this demo, I'm going to show how to use Lifelines 2 to find patients who experienced decreased renal function, possibly as a result of the administration of their radiology contrast procedures. This is indicated by their creatinine high events within 2 weeks after a radiology contrast. Here I have loaded a data set of 3,598 patient records. Each record is represented by a horizontal strip containing the patient ID and the events in the patient's history. Each event is represented by a colored triangle on the timeline. From the legend, I see that creatinine high, normal, and low are in red, blue, green, respectively. Scrolling down, I see that radiology contrast events are in yellow. To examine this data better, I align the patient records by their first radiology contrast events and rank by the number of creatinine high events to bring the most severe patients up top. I immediately realized two things. One, some patients have chronic renal deficiency and they should be removed because their condition is not related to their radiology contrast. Two, some patients have more than one radiology contrast event, and this needs to be taken into consideration. To remove the chronic patients who have at least 4 creatinine high events prior to a radiology contrast, I choose to filter by the number of occurrences on creatinine high. I set the number to be at least 4, and the filter scope to be before the alignment. The blue highlight indicates that these records are selected. For our purposes, we want to remove them. I click on Remove Selected, and also save the remaining records as a new group. Let's call it non-chronic. Next, instead of aligning by every patient's first radiology contrast, I align by all radiology contrasts in all patients. Lifelines 2 asks me whether I will proceed, as some patients will be duplicated. I click on Proceed. Then I bring up the distribution of creatinine high events across these records and zoom into the granularity of days. As I drag from day 1 to day 14, I'm selecting all patients who have at least one creatinine high event within 2 weeks after any of their radiology contrast events. This time I will click on Keep Selected and save these records as another group. Let's call it Candidates. Looking at this group, we see that this is more of an overestimate. Many of the patients do not exhibit patterns of contrast-related renal deficiency. It would be better if we restrict only patients who have a baseline of normal creatinine prior to their radiology contrasts, without creatinine high events between. To do this, I will use the sequence filter, specifying only for patients who have at least one creatinine normal reading, followed by no creatinine highs, followed by radiology contrast, and finally followed by at least one creatinine highs. Likewise, I'll click on Keep Selected and save this as a final group.
All right, let me just stop here and just let you focus on the control panel, as I said, is the key thing. The display is one part, and you saw how that was used and even selected on the summary, but this align, rank, and filter methodology became the central way of thinking about temporal data sets. That was new. This was very different from the traditional SQL queries, and the database experts and the physicians could not write the SQL they wanted to accomplish these kind of queries, and also the joins, the self-joins that were needed, took days to run. And so the strategies that we adopted and the algorithms and the data structures became a unique contribution as well, and that's recently been finally accepted for the IEEE transactional knowledge and database engineering. And so it's interesting how the user interface topics lead to good challenges for algorithmics and for the design of efficient algorithms that scale to dealing with much larger sets. I think also interesting is the idea of negation queries that say the absence of a certain event is really important. So you may want to look at patients who have a heart attack, they receive a certain treatment, but they don't get a stent, and then they have another heart attack. And writing those kind of queries is notoriously tricky in SQL. Any questions about what you've seen here? Yes, thank you.
Is this data pre-indexed to increase retrieval speed?
No, I mean, this is, you know, we extract from the large relational data set of their hospital records, selecting only the cases in these 3,600 cases in this situation, and then it's loaded into Lifelines 2, and then it runs all, you know, high-speed store. I don't know if, David, you want to add to that?
Yeah, it's not, so this software is not connected directly to the database. We just basically extract the data and put it in a plain text file, and then load it into.
Right. And we've worked, the way we worked, I was describing, how do you validate the utility of this tool? This is not easy to learn. It requires a fresh way of thinking and a fresh way of working on the data sets. And David worked over more than 2 years with 8 case studies on different problems that came to us from Washington Hospital Center, one of the MedStar hospitals in Washington that was supporting this work, and 3 other case studies that involved things like graduate student records and students who are, you know, take courses, submit PhD proposals, have job interviews, have a defense, or whatever they do, publish a paper, and looking for patterns within that kind of data. One of them was a Texas FBI investigator looking at cell phone patterns of drug dealers. And so we were able to work on a variety of tasks. So we believe this is relevant not just for medical data, but any kind of personal histories, legal histories, where there are event data with timestamps. And the alignment on sentinel events is the key concept that gets you started, lets you see what's happening. Then you can look at what happened before and what happened after. Yeah, question?
One thing that impresses me here is that this data, it seems like something, you know, that is entered by doctors or humans anyway, right? So one of the huge issues that a lot of people run into in visualization is being able to get data that has, at least if it's categorical, has homogenized names, right? So this creatinine high, I mean, did you run into any issues with that?
Well, it's a whole much longer talk. But certainly the data cleaning is a serious problem. The medical data in most of these electronic health record systems is really bad. And there's lots of bad things of people admitted to emergency room 14 times but discharged only twice, you know, or, you know, a variety of strange things that happen. People admitted to the intensive care unit when they're dead. You know, we have all kinds of things like that that show up when you start looking at the data. They never knew this existed. So the data cleaning is one problem. You had another point about, you made a good point about the categorical data, the creatinine high, normal, and low. Those didn't come that way. Because we focus on categorical temporal data in this system, we converted the numeric readings into their standard ranges of high, medium, and normal. So, and I might make a further comment. In this implementation, we restricted to point events. You noticed before, the Lifelines 1 had interval events. And we found that modeling and actually what's in the database are really point events. You have to infer that if they were admitted and then discharged, they remained in there, but that's an inference, and we wanted to represent the actual data. So there is some manipulation problems that you have to deal with, and the focus here, I think, as a research tool, as a research innovation and contribution, was to enable powerful operations on this kind of data. You want to?
So you're putting that sort of before, you know, or I'm putting that cart before the horse here, right? You're dealing with that before you even get to this stage.
That's right. We convert everything. It's got to play according to those rules, and you've got to have a timestamp of a fixed point where the event happens. Some events you're not sure where they happen, so you have to establish, you know, a point where that happens. Okay. You get, I mean, many messages. So we were working on heart attacks. We do search on heart attacks, rank by the number of heart attacks. We see one patient with 6 heart attacks. We say, my God. And you look at the data, actually, there's only 2 heart attacks, but each one was recorded by 3 different physicians. So you have to begin to learn how to clean up the data and find out that if they're within 24 hours, it's probably the same heart attack, and begin to clean the data. But the power of visualization, as my opening argument was, that it exposes all these things that are a mess in existing data sets. And if we only provide the incentive for people to make cleaner data, we will have done a good job. I do think our payoff is we're giving physicians and others powerful tools to let them answer questions that they just could not answer before. David, you get the last word. Anything else to say?
I think you pretty much got it covered.
All right. Good. I just want to move on because I'm really out to get into network structures, but just a brief comment about tree structures and our work on tree maps. This was ours with the gene ontology, a 19-level hierarchy with 14,000 nodes. And you can download this one for free from our website. But the most famous one is Martin Wattenberg's contribution. I was pleased to work with him in the period 1999 and 2000 when he created this version for smart money. There are 11 industry groups showing 600 stocks. The green stocks are rising. The red stocks are falling. The area indicates market capitalization. Okay, so Microsoft at that time was the biggest of them. Apple has now superseded them. If I had a web connection, you could see that Apple's grown bigger than Microsoft, which is pretty interesting to see. Now, sometimes, and I'll show you some examples, you get some pretty interesting images. See anything interesting here? It's a particularly bad day. Green one. I heard it. Not the big green one, but the little green one. There is a single green dot on this day. And it's not just a little green, it's bright green, right? And when I went and clicked on it, when you click on these, you get a mountain of data, 20-year trading history, insider trading, and reports about the corporation and so on. It turned out that that little green dot was the A&P Trading Company, which that day bought the Pathmark chain of grocery stores. And it went up 6% when everything else went down. So I find this a charming and pretty compelling example because it tells you that visualization gives you answers to questions you didn't know you had. Okay? And that's another one of the secrets about InfoViz. You can write as many statistical algorithms to detect as many patterns as you can think of, and there'll always be one more you didn't think of. Yet, when you see these patterns emerging like this, if your eye is trained, if your mind is alert, you'll see the kind of things that you just couldn't have anticipated. This is a more ordinary day. Financials were down, healthcare was down, except this one was up. So what's different about that one? Technology had a pretty good day. Energy had a pretty good day as well. Here's some few, for those who like better news. You see better news, but do you see anything unsettling? Something in basic materials. Anybody guess what this cluster is?
What was the topic?
Gold. You got, oh, I guess I said it. Gave it away. Right. This is a little group that travels quite differently from the market. When the market's happy, gold people are unhappy. So they trade down when they're contrarians. And so these are the gold stocks. And so I've come to know where the gold stocks are, where the defense industry people are. They're over here in a block, and various utility groups. And among the technology groups, I've come to know those sectors. Other people have come up with versions of tree maps. It's great fun when you start an idea and it just goes to places you never would have thought of. A 26-year-old Argentinian named Marcos Westcamp built a news map. And the area is the number of articles on the web from the Google News aggregator. And it has 20 countries, so you can compare how stories are being shown in the US or what prominence they're getting in the US versus England or France or Canada or whatever. And if you click on it, you'll get a brief pop-up, details on demand, and then you can go see the related articles. In this case, there are 563 articles about US jobless rates. You can try that, newsmap.jp. We work with the Hive Group, and this is their famous supply chain management tool that 3,000 people in the Marine Corps use every day to manage every T-shirt and tank that gets shipped. The red boxes are the ones that are either delayed or had a high rate of failed equipment that was included in the shipment. But they've gotten very good at building tools for real users, supply chain, security, banking, a lot of those applications. Spotfire added tree maps a couple of years ago. Here's a bond portfolio analysis that shows different sectors of energy, manufacturing, construction, and so on. And the New York Times began to use tree maps in 2007. Here showing 6 variables for the automobile industry, which things are growing and failing. And they've continued to use tree maps. Now the Washington Post has started using tree maps as well to show Obama's schedule of visits, where he spends his time, which agendas, which parts of the country, which organizations. And then other people like Michael Balzer in Germany developed Voronoi tree maps. Very elegant, lovely looking, kind of looks like a leaf structure, but this one the New York Times quickly grabbed up to show Voronoi tree maps used for the inflation. And just for scalability, Jean-Daniel Fouquet and Catherine Plaisant worked on the million node tree map. This is all the file directories and the servers of the computer science department. I could talk for an hour about what was discovered here. The main starting point, all this gray area, was ungarbage collected, wasted space. That was about 7% of the data that nobody knew about. All right, so I turn to the last topic, and I'm sorry I'm a little late. I know some of you may have to go, but give me a few minutes to talk about network visualization, which I saved for my last part of the work because I always knew it was the more difficult challenge to deal with. And you can tell it's difficult because Manuel Lima labeled his page Visual Complexity, and he shows 700 different tools for visualizing networks that largely show these beautiful, colorful bowls of spaghetti. They may be colorful, they make nice posters, but they don't always inform and provide insights. And so we began to work on tools that would enable you to find insights in network data. This is Adam Perez's PhD called Social Action, showing a data set of terrorist attacks. University of Maryland keeps the global terror database, GTD, of 80,000 terror attacks in the past 28 years. This just shows some of the data. But I'm going to show you a video of the most remarkable, unbelievable visualization that we got by responding to the request of the journalist Chris Wilson, Slate Magazine, who brought us Senate voting data from 2007. The red Republicans and the blue Democrats are all thrown in here. 100 senators, each one connected to everyone else with a link whose strength is the number of times they voted the same way. Okay, there were 360 roll calls, and the most common pair, the strongest link, is, ironically, 303 similar votes by the senators from Maryland, Cardin and Mikulski. Okay? And then these are the other pairs that go declining numbers. So we throw all this into the Fruchterman and Reingold layout algorithm, and now we begin to filter out the ones with the low connectivity strength, 110, 120, 130, 140 links. We throw out the lightweight links, and we see John McCain out campaigning for presidency, wasn't connected to anybody, and he drifts off. And now, the unbelievable, amazing Brownback, also campaigning for president, drifts off, and you get this unbelievable result of a complete partition of the blue Democrats and the red Republicans, and the two independents, Lieberman and Sanders, vote with the Democrats. And then you see a few in the middle. Olympia Snowe of Maine, Arlen Specter of Pennsylvania. And these three were the three who ultimately, 2 years later in 2009, voted for the Obama stimulus package in January 2009. So if you want predictive power, I don't claim it, but it was pretty compelling to see, and you came to understand where the patterns were. And the too good to be true part was the red Republicans moved to the right and the blue Democrats to the left. We didn't plan that, but sometimes sometimes visualizations are too good to be true. Now, also furthest from the Republicans, Chris Dodd of Connecticut, and Biden, Kerry, and Obama. What do you know? Okay, so if you're looking for understanding the political structure, this begins to give you. Now let me go a little further, and we're going to continue this filtering process to look at really the high volume connectivity. But first we're going to turn off the layout algorithm, turn off Fruchterman-Reingold, freeze the topology, and now get rid of the 190, 200, 210, 220, 230s, 240s until we see this remarkable pattern where the Republicans in 2007 have lost their party loyalty or cohesion, and only Isaacson and Chambliss are still connected. Whereas the Democrats have got their act together, although Biden, Dodd, and Obama are not really connected. The rest of the group are, and if further analysis shows you actually there's a group of Midwestern Democratic senators who have a quite cohesive voting pattern. They vote as a bloc, and they're pretty consistent in their strategies of voting. Let me just pause. Any questions about this? Yeah.
This is very surprising, actually, because I feel like Democrats can't actually.
But I think it's certainly interesting, and you know, please do it. And actually, I'll say please do it using our tool. Well, just to finish up on social action, Adam's work was done. His publication, his dissertation, was validated by 4 case studies. One was the journalist, the bibliometrician, terrorist analyst, and organizational analyst all produced publishable papers using social action that they gave very strong credit for its success. So we took the best ideas and we began to build a new tool. And this new tool was meant to explore the social media that I highlighted in my opening slides. And it's sort of the traces, the tweets of the world, the Twitter comments, the Facebook postings, and so on, leave traces of our presence here. And a good tracker can tell if these footprints in the sand are a man or a woman, if they're walking together or not, if they're walking quickly or slowly, if there's a dog with them or not, or maybe the same pair of footprints return an hour later, and they can tell which are the new ones and which are the old ones. And we wanted to allow people to do that as well. The tool we built, NodeXL, and you have the flyer and the handout, is really simple, but powerful. And you can type in your network. Anne invited Bob on a date. Bob invited Carol. I just literally typed it in, and then you say, draw this thing. You get the network. Okay, in this case, a directed graph. You can control its visual patterns. We'll make the girls pink and the boys blue. We'll give the labels to be that, and we could code more. If you do the Senate data, and the Senate data is free to download, so you could check out our, you can do this in NodeXL, and it looks a little different from social action, but the basic idea is there. And if you set the slider to 65% similar voting, boing, you get this drawing, just quite similar to what we saw before. Free to download, open source, supported by Microsoft Research, I'm pleased to say, over the last 3-4 years. We're up to version 133. It's just a great project. It's really a game changer in the sense of democratizing social network analysis. We make it possible for anybody to do this. In fact, our easy starting point, if you look at the import box, the import lets you import your own email. It lets you import Twitter, Facebook, YouTube, and other data sets. And we're building an increasing set of the spigots or importers that let you import, and I'm going to show you some of the results of those things. This was my student class project, and there's 2 interesting data sets that were available on data.gov. This was the White House visitors log, and here we see the people who came to visit, including Thomas Daschle, Ed Kennedy, Michael Moore, Jesse Jackson, and here's who they visited. This is the president, and then you see different presidential staff members, and you can see the frequency in which they visit. Here you see the Senate co-sponsorship pattern. It's hard to see, but this big picture is Hillary Clinton. She sponsored the most bills during the 2008, I guess it was, season. Maybe it was 7, I'm sorry. But the size indicates the number, but she had only a moderate number of people who co-sponsored with her. Ted Kennedy, who sponsored fewer bills, had many more co-sponsors. Everybody wanted to co-sponsor. The blue ones are Democrats and the red Republicans, and you'll see there are some Republicans who will co-sponsor with Democrats and back and forth. you know, they go, the arrows go both ways. I'm not sure you can see that here. And sometimes there are Democrats ready to just co-sponsor with Republicans. So you can begin to find the patterns of who works with whom. Okay? Mark Smith, my colleague, collected this data from Twitter using NodeXL. Last year at this time, there was a conference at NYU called Workshop on Information and Networks, and about 80 people, and there was a feeling that there were sociologists in the room and computer scientists, but they weren't talking to each other. So Mark grabbed the tweet stream with the hashtag Win09, and sure enough, there it is. The sociologists, including Barry Wellman, some of you may know here, sized by the number of followers that you have, and these were the computer scientists, and there was one bridge person across them. So that separation was quite nicely manifest in the tweet stream. We've looked at other things, like we thought HCI as a topic, and in fact, HCI is ambiguous because there's two clusters here. Human capital index is one use of HCI, and human computer interactions here. The color coding by the clustering algorithm in NodeXL shows you the different clusters. And the big outlier, anybody know RKMT in the HCI field? Jun Rekamoto, professor at University of Tokyo and head of the Sony Computer Science Laboratory, has 174,000 followers. So he stood out, and you know, enormously in this graph. And if you know some of the people, there are other characters you may recognize. The World Wide Web Conference, April of this year, shows a very tightly connected group. This is a heavy tweeting group. Very few people on the sidelines that are disconnected. Everybody knows everybody else in that community. They're quite well connected. Okay? And Kodak is another example of a disconnected community. Kodak is sort of a dying brand. It does not have a social media strategy. And there are various groups who talk about Kodak, like this one and this one, but they're not really connected up, and there are a lot of people on the sidelines who are just not connected to anybody. Oil spill produced another one. Early on, Mark began to track every morning the oil spill topic, and you get this very strong pattern. This cluster, I hope you can see it up here, this cluster on the top are the public interest and news groups like USA Today and NPR and environmental groups, and they're all talking to one another. And down below are the climate skeptics and the Tea Party people, and they're talking to one another. And there's only a few links that go across these two groups. And then there's a lot of people on the side who, that topic is not a well-formed topic, and so it has a lot of sideliners. Another way of looking at the data is not just by the force-directed layout, but by laying out using what we call semantic substrate, here layout by the number of followers and by the number of tweets. And the extreme outlier in this case is Zephoria. Anybody know Zephoria? Dana Boyd, who's Microsoft research here in Boston and the Harvard Berkman Center. She tweets a moderate amount, but she's very followed. She's the most followed person. She's just great. If you read her tweets, they're really fascinating. There's interesting stuff. And a lot of people listen to Dana Boyd. She really stands out as a unique leader. And this is her most recent tweet here at the CHI 2010 conference. Now, the place you want to be is below the diagonal. And my buddy Mark Smith is over here. And I'm not so active, but I'm over here. The people below have a reasonable number of followers, even though they're moderate tweeters. The people above the line are the losers, above the diagonal. They're tweeting all the time, but nobody cares. And the most extreme case is something called VoiceBot2, which tweets all the time, but nobody really cares about what that VoiceBot is. So you know, in different ways, begin to extract and understand. All right? Now, NodeXL lets you import from Flickr as well. And Eduarda Mendez, we do have a book about this, and her chapter is about Flickr. And so she tells the story of how she did this. But she searched for the term mouse on Flickr. And the clustering algorithm in NodeXL did a beautiful job of finding the yellow, blue, and red ones. And what they represent is the computer mouse. They represent the animal mouse and Mickey Mouse. And so here you have a way of doing word sense disambiguation by looking at the clustering. And it's just another very nice story because the clustering algorithm produced such a solid, in this case, very strong and compelling separation of the three uses of the term. And I come to the close here with my own Flickr network. And here you can see on the right is my family network, and the left my professional network. My two daughters are over here. And there's 39 pictures with Sarah and Anna in that picture, in the same picture. And then Sarah married Mark, and of course I took a lot of pictures. 93 of them have the two of them together. And so you see them. You get my sister over here and her family, and then other cousins that are a little more distant and less organized. But the color coding did the clustering in pretty much a good way. The green clusters are the people in the University of Maryland HCIL group with a couple of mistakes. Jacob Nielsen and Claire Marie Carat got included in our group. But that's okay. Clustering is not a perfect. I guess George Robertson, often a visitor, or we work with him a lot. So these people got really closer to the HCIL group. And then you have other professional connections over here and a different cluster that's separate over here. So this took, I have some 40,000 pictures on Flickr, and they're tagged and annotated with people and names. And so it's a pretty rich source to be able to collect this kind of data. So you can do this too, is my point, with Flickr networks and YouTube networks as well, by extracting these different networks. On the Twitter graphs, there's 5 kinds of networks. You can get follower graphs, following graphs, retweet graphs, replies, and mention graphs. So it's pretty nice that what used to require a lot of programming, handling APIs, and now becomes something that's just a checkbox and being able to do it. So this is the plug for the book. It's just out this month and on Amazon for, I think, just around $30. It's all color, and the first part talks about these social media. The middle part is sort of a how-to part, but the remaining half is 9 chapters that show you how to do this stuff by other people. They're contributed chapters to analyze email, threaded discussion lists. Oh, there we go. Threaded networks, Twitter, Facebook, World Wide Web, Flickr, YouTube, and Wiki networks. And we continue to add more importers or spigots. The project is supported by Microsoft Research, and with their encouragement, we've established the Social Media Research Foundation, which is a nonprofit meant to keep this going. We're beginning to look for sponsors and supporters for this to be in the same form, we hope, as Mozilla Foundation or Apache or Linux Foundation to keep this going. The group at Maryland has been a key force for that. Mark Smith, and this is the Microsoft Cambridge group and Microsoft Seattle. Then we have Yuri Leskovich at Stanford and Washington and Cornell University, and other people who play into this from time to time. So I hope you'll take a look at that as well. So I close with the notion that the work we do should have value and importance, and I see this as a sort of focus for computer scientists of all kinds and other professions too, to try to make the world a better place. And the UN Millennium Development Goals were set out in 2000, but sadly in the 10 years since, the progress has been very modest. And I'd like to believe that these social media tools can help build better worlds and work on national and international priorities. To that end, we got support from National Science Foundation to run 2 workshops on what we call technology-mediated social participation. And it was to write a research agenda about how to apply these successful social media to national priorities like disaster response, community safety, healthcare, energy reduction, and so on. And I'm pleased to say the 7 papers from those 2 workshops will appear as a special issue of IEEE Computer in November, and that will enable us to get the story out and let other people see it. So I hope you'll think about, and I hope our profession will take these as meaningful challenges to, that we apply ourselves to, and we put this powerful technology to good work. And I close, invite you to Maryland, either on the website or in person for our 28th symposium at the end of May 2011. Thank you for staying. Thank you for your time and attention. to go, but I'm glad to stay for questions if people have, or challenges.
If you are challenging, make sure to smile. We can take 1 or 2 questions from people who can still.
Yes, thank you.
I was wondering what sort of advice you have for doing data cleanup, whether or not there's HCI for tools doing the cleanup, or if not HCI, what are some guiding
It's
techniques?
finally become a popular topic. I must say I use Spotfire as my first tool. When I get something, I throw it into Spotfire and I just look at the data, and I can see the kind of things that.
Does Spotfire just open anything? Or
Yeah, anything that's in a spreadsheet. I even cut and paste off of a web page. It's CSV or spreadsheet format, rows and columns. Sometimes you do have to do a little bit of formatting, but in general it loads pretty well. There are other tools, Tableau I should say also as a commercial tool, but there is a growing movement, so-called data wranglers, not just cleanup, but data wrangling to rearrange the data and put it in. And with the successor work with David, one of our students now, Angela No, is working on a general purpose importer tool that cleans up the medical data, formats it, and gets it right. So I think there's still a lot of work to be done. I am surprised that there isn't more of a commercial set of tools that essentially do lint or find trouble in data sets. I still think there's an opportunity to do that. And I must say, as we get into it, the variety of kind of bad data is so rich that I could just see, for textual data, for, numeric, tabular, tree, and so on.
One comment I have is, I guess I use a lot of sort of interactive tools, and you kind of write some code and import some stuff, filter, and do that stuff. And I wonder whether HCI is the right, sometimes these HCI tools are too monolithic, and what is the balance there?
Of extensibility, is that what you're looking
Or
for?
of being able to script and being able to express.
Yeah. I mean, a lot of these tools have open-ended facilities that let you add features. I think with NodeXL, you're welcome to write, Excel macros, which will let you do other kind of cleanups, and people do that. We were trying to make a tool that didn't require you to use any Excel macros, so that was one requirement. But I would say there's still room for people to do data cleaning, as a general purpose tool. Another question?
Yes. I've seen demos of Spotfire and other tools like that. I've never actually used it, but what I'm wondering is, if you're not an expert user at any of these tools, is there a danger that I can see with Spotfire where you can manipulate the charts and turn them around, that you're looking at something on a 2D representation on a piece of paper as opposed to something like Spotfire? Is there necessarily, if you're looking at the same data, is there necessarily a danger that on the 2D representation that you're going to perhaps draw a wrong conclusion, as opposed to, or is it less likely that you're going to draw a wrong conclusion with a 3D representation like Spotfire?
Oh, well, I'm not a great fan of 3D representations. In fact, there's very few examples of where there really is a payoff. It showed it there as a 3D, as that example came to me. But generally, we don't use 3D representations. So 2D is much more effective, and multiple 2D representations are really the way to look at higher dimensional data. There's very rare cases. There's a dozen studies where designers of 3D tried to show that it worked out, but in every case, it was either no better or worse. So 2D scattergrams and these multiple visualizations are the way to go. Now, I do take seriously your point, which is you can be misled by these visualizations. There are problems of occlusion. And if you choose the wrong color coding or size coding, you will emphasize certain features more prominently, and that may be misleading. So every time you do that, I hope my argument about integrating statistics with visualization is clear to you, that you want to use the visualization and the statistics together. Try one, do the other, verify your results, go back, take a look, eyeball it, and do the statistical analysis. To that end, Spotfire has a very nice connection with SAS as well as R, and so it allows you. And I guess what others? There's some stat package they bought recently that's integrated with. What's it, S plus? Right. S plus is now part of Spotfire, so we're more closely. So that integration is really important and valuable. All right.
One last question. How do you,
Yeah.
how do you prototype these complicated interfaces? Every interface toolkit I've ever used requires you to specify all sorts of details before you can even make the thing go. And I'm curious whether toolkits are moving in a direction that allows you to sketch.
There are lots of good toolkits. Jeff Here's Prefuse and ProtoViz and Piccolo are all toolkits on which you might start as a platform. And I would say there's more and more of the things you want to do are done by the standard commercial tools. Lately, I get papers from the InfoViz conference, and I look at the paper, and they built something when it could have been just as well done in Spotfire, and Spotfire would do so much more for you. So we're sort of reaching a maturity where the commercial tools are pretty good, and you have to have a stronger case to justify building something new. Now, once you decide to build something new, I would say there are some widget sets and some things you can build on, but it's still a pretty down back in the guts of writing code. Is that fair, David, or you want to? Pretty much. Yeah, you're back down to. Right? I don't think we have, strong general purpose toolkits that have all the things you want in them. You're going to wind up writing things, and especially if you're doing something new at this point. I think it's sort of like the way database systems were 20 years ago, where, you created new things, but by a certain point, the database tools were really pretty good, and the justification to build a special purpose one had declined substantially. And so I think we've got good commercial tools, and you have to find the ever more exotic situations or new situations by which you justify building your own. And one more.
What are the costs starting right now?
I thought they start at 37 after. All right, that's fine. Please come. Thank you.